Welcome back to Sarah's story. In part one, we met a woman in her 50s whose health seemed to change almost overnight. A long list of symptoms appeared: fatigue, pain, swelling, digestive problems, and cognitive changes, and no single diagnosis could explain all of them. But hidden in Sarah's history and laboratory testing were several important clues. Recent travel, years of working closely with animals, and an unexpectedly high level of BPA. None of those clues could explain her illness by themselves, but when we began looking at how they might affect detoxification, the lymphatic system, inflammation, and cellular energy, a much larger biological pattern began to emerge. And like many people with sudden unexplained symptoms, Sarah looked for a single answer. Given her extensive travel history, parasites seemed like a reasonable possibility, so she completed a parasite cleanse, but her symptoms didn't resolve. We also considered other infectious possibilities, including Lyme disease and some of its common co-infections. Based on her history, symptom assessment, and the overall clinical picture, they did not appear to be the primary drivers of her illness, even though they remained part of the broader differential diagnosis. In part one, Sarah's unusually high BPA result gave us our first major clue. But when we looked at the rest of her environmental testing, BPA was clearly not acting alone. One of the findings was an elevated metabolite of organophosphate pesticides. Organophosphates are a class of insecticides that have been widely used in agriculture and in some cases around homes to control insects. A metabolite is a breakdown product that's formed after the body processes a chemical. And rather than measuring the pesticide itself, many laboratory tests measure the metabolites because they provide evidence that exposure has occurred. Organophosphate pesticides are known to affect the nervous system by inhibiting an enzyme called acetylcholinesterase, which is essential for normal nerve signaling. This was one piece of evidence suggesting that Sarah's nervous system may have been carrying an additional biological burden. Other toxins detected were thallium and several mycotoxins from mold, and now the picture looked very different. This wasn't a story about one plastic chemical. Sarah's body was dealing with several different categories of environmental burden at the same time. And that raised the next question: what could this combination be doing to her biology? These compounds came from different sources and entered the body through different pathways. Some may have come from food, others from consumer products, household environments, occupational exposures, or simply the accumulation of everyday life over many years. But once inside the body, they did not necessarily remain separate biological problems. Human physiology doesn't compartmentalize exposures in the same way laboratory reports do. Instead, many chemicals converge on the same biological systems where their effects can overlap and sometimes amplify one another. Many of these compounds are capable of increasing oxidative stress and creating patterns of dysfunction that extend far beyond the original exposure. Now, this overlap mattered. Rather than thinking about pesticides, plastic solvents, mold-related compounds, or heavy metals as isolated findings, it became more useful to ask what they were collectively doing to Sarah's biology. Different exposures can produce remarkably similar downstream effects. particularly if they're converging on energy production, detoxification capacity, inflammation, nervous system function, and cellular resilience. And although Sarah described her illness as having a sudden onset, our conversations gradually revealed a different story. As we explored her history in greater detail, it became clear that she had been pushing through fatigue and stress and subtle health changes for much longer than she initially realized. The dramatic decline wasn't necessarily the beginning of the problem. It was the point at which her physiology could no longer compensate. And what appeared to be a sudden illness was more likely the culmination of years of accumulating biological stress that had finally crossed a threshold. Detoxification is not a single event. It's a complex physiological process that depends on multiple organ systems working together efficiently to identify, transport, chemically modify, and ultimately eliminate compounds the body no longer needs. Every step must function well for the process to proceed smoothly. Most people think detoxification happens in the liver, and that's true, but it's only part of the story. Before anything even gets to the liver, it has to be released from the tissues, transported through the blood or lymphatic system, processed, and then eliminated. Every one of those steps has to work reasonably well. Only then can it undergo the biochemical transformations that make it more water soluble and easier to eliminate. These chemical transformations occur through a series of carefully coordinated biochemical reactions involving numerous enzymes, nutrients, transport proteins, and cellular energy. Once compounds have been modified into forms the body can eliminate, they still require healthy transport and functioning routes of elimination. They may leave the body through the bile, into the intestines, through the kidneys, into the urine, through perspiration, exhaled air, or by several other physiological pathways. And each step depends on many of the same biological systems we've been exploring throughout this biology series, including mitochondrial function, nutrient status, cellular energy production, membrane transport, circulation, lymphatic drainage, liver function, kidney function, gut health, and inflammation. And if you'd like a deeper explanation of these processes, I've covered them in detail throughout the biology series. Anyway, if any portion of this integrated network becomes impaired, the efficiency of the entire system may be reduced, even when detoxification enzymes themselves are functioning normally. And equally important are the transport systems themselves. The lymphatic circulation, healthy blood flow, adequate hydration, normal bowel function, and the movement of body fluids all influence how effectively compounds are carried from the tissues to the organs responsible for processing and elimination. Detoxification is therefore not just about chemistry, it's also about movement. And as I reviewed Sarah's history, several observations kept drawing my attention. She described significant swelling and fluid retention. Laboratory findings suggested ongoing inflammation, and her body seemed to have great difficulty recovering after the sudden change in her health. But before we could think seriously about supporting detoxification, we first needed to understand whether Sarah's transport and elimination systems were functioning efficiently. If those systems were struggling, simply trying to increase detoxification without improving movement and elimination might never fully address the underlying problem. The lymphatic system is one of the body's major transport networks. It collects excess fluids, proteins, cellular debris, immune materials, and other compounds from the tissues and carries them back towards circulation, where they can be processed and eliminated. But unlike the cardiovascular system, the lymphatic system does not have a central pump. Its movement depends heavily on muscle contraction, breathing, hydration, and physical activity. Sarah had once been extremely active, but as pain, swelling, weakness, and fatigue restricted her movement, one of her systems responsible for clearing material from her tissues may also have become less efficient. This suggested a vicious cycle. Inflammation and swelling reduced movement, while reduced movement made it harder to clear inflammatory material and fluid. So that changed our starting point. The first priority was not to push the body to release more toxins. It was to improve its ability to move what was already there. And rather than beginning with an aggressive detoxification program, we focused on supporting the physiology responsible for transport, communication, and elimination. Each intervention was selected because it supported one or more of these biological processes, not because it was marketed as a detox supplement. In many cases, supporting these foundational systems is what allows the body's own detoxification mechanisms to function more effectively. When transport improves, circulation becomes more efficient. Tissues receive better oxygen and nutrients. Inflammatory byproducts are removed more effectively, and the organs responsible for elimination can perform the work they were designed to do. The goal was never to force detoxification. It was to restore the physiological conditions that make detoxification possible. When people hear the word detoxification, they often think about products that remove toxins. That was not our first priority with Sarah. Before asking her body to eliminate more, we focused on the biological systems responsible for transporting, processing, and elimination. Each recommendation was chosen to support physiology, not to chase a specific toxin. And as those systems became stronger, Sarah's own detoxification capacity could improve. This systems-based approach guides my work. Identify which biological systems need support, then restore the conditions that allow recovery. Once we recognized that impaired transport and elimination might be contributing to Sarah's condition, the treatment strategy became much clearer. We also paid close attention to pacing. Her body had already shown us it could become overwhelmed if we moved too quickly. This wasn't a dramatic cleanse. It was a gradual process based on physiology rather than forced detoxification. Recovery wasn't driven by supplements alone. They were only a part of a much broader strategy. We also reduced new environmental exposures, modified work and daily activities, improved nutrition and hydration, supported sleep and gentle movement, and respected the pace at which Sarah's biology could recover. Healing came from many coordinated changes working together over time. One of the biggest misconceptions about recovery is that it comes primarily from supplements. In reality, supplements were only one part of Sarah's plan. Recovery was the result of many small changes working together over time. Sarah didn't recover because of one supplement, one laboratory test, or one intervention. Recovery required time, patience, and learning how to live a little differently while giving her biology the opportunity to heal. Sarah's improving laboratory results were encouraging, but her recovery was not smooth or predictable. At one point, detoxification was advanced too aggressively, and she developed a significant Herxheimer-like reaction. Instead of feeling better, many of her symptoms temporarily intensified. Now, many practitioners describe these reactions as occurring because detoxification is happening too quickly. And there's truth to that explanation, but it's only part of the story. The more important question is why the body is struggling to tolerate that increased detoxification. Mobilizing compounds from tissues is only the beginning of the process. Once released, they must be transported through the blood and the lymphatic system, chemically transformed by the liver, and ultimately eliminated through the bowels, kidneys, and other routes of excretion. If those transport and elimination systems can't keep pace with what is being mobilized, compounds and the inflammatory signals associated with them may temporarily accumulate in circulation, and the result can be a worsening of symptoms rather than relief. In other words, the problem is often not simply that too much detoxification is occurring, it's that the body's biotransformation and elimination systems are temporarily unable to keep up with the increased demand. That realization gave us important clinical information. Sarah's body was capable of responding, but it was also telling us that we had exceeded its current physiological capacity. So we slowed everything down. We returned to the foundations, supporting hydration, lymphatic movement, bowel function, and overall physiological stability before gradually moving forward again. The goal was to strengthen the systems responsible for transport and elimination before asking them to handle additional work. This was not a failure of the path. It was an important reminder that biology has its own pace. Only after Sarah's physiology became more stable were we ready to see whether those changes were reflected in repeated laboratory testing. The important point isn't memorizing these numbers. It's that we saw improvements across several completely different categories of environmental exposures, and this suggested Sarah's overall physiology was functioning more effectively. Some were plastic-associated chemicals, others were mycotoxins produced by molds, while others were heavy metals. They entered the body through different pathways, behaved differently within tissues, and were processed through different biological mechanisms. That pattern is particularly meaningful. Rather than observing an isolated improvement, we saw measurable reductions across plastics, mycotoxins, and heavy metals. Although these compounds differ in their sources, their chemistry, and biological behavior, they all rely on the body's transport, biotransformation, and elimination systems. And viewed together, the findings suggested that Sarah's physiology was functioning more effectively than it had several months earlier. The results didn't mean that Sarah's recovery was complete, because environmental exposures continue throughout life, and no laboratory report represents a permanent finish line. Instead, the findings suggested that Sarah's physiology was becoming more resilient and more capable of responding appropriately to the environmental challenges that all of us may encounter. So for the first time, we had objective evidence that was beginning to reflect what we hoped was happening physiologically. But laboratory numbers were only one part of Sarah's progress. Sarah's laboratory results gave us measurable evidence of environmental burden, and later measurable evidence that many of those levels had improved. But a laboratory report can capture only a small portion of the influence shaping a person's biology. Sarah's health had also been affected by her work environment, travel history, diet, physical activity, infections, stress, medications, her nutrient status, and the condition of her digestive and elimination systems. As Sarah's story unfolded, it became increasingly clear that no single exposure, laboratory result, or biological pathway could fully explain what she was experiencing. Her health reflected the cumulative effects of many interacting influences over time, each putting pressure on the same physiological systems. Just as an aside, scientists now use the term exposome to describe this broader biological picture. The exposome encompasses the totality of environmental exposures experienced throughout life, including all of those things like diet, environmental chemical exposure, infections, and so on. Now, Sarah's story illustrates why this perspective matters. Her laboratory results, symptoms, health history, and response to the treatment made the most sense when viewed together rather than as a series of unrelated findings. Looking at the whole picture allowed us to identify patterns that would have been easy to miss if we had focused only on one toxin or one symptom or one laboratory value. And that's also why Sarah's story is not evidence that one detoxification program or any single protocol will work for everyone. Every individual brings a different lifetime of exposures, unique physiology, different compensatory mechanisms, and varying capacities for adaptation and recovery. The value of Sarah's case lies not in copying her treatment plan, but in understanding the biological reasoning that guided it and how integrating her exposures, her symptoms, her history, and physiology changed the direction of her care. After slowing the protocol and giving Sarah's physiology time to stabilize, she initially experienced meaningful improvement. But the progress did not continue evenly across every aspect of her health. Her sleep became disrupted again. Fatigue returned, brain fog persisted, and muscle pain worsened, even while repeat laboratory testing showed substantial reductions in BPA, mycotoxins, and several heavy metals. At first glance, those findings appeared contradictory. If the environmental burden was decreasing, why wasn't she feeling consistently better? In reality, the laboratory results and her symptoms were describing two different biological processes. The laboratory was telling us that her body was becoming more effective at transporting, processing, and eliminating environmental compounds. Her symptoms, however, reflected the condition of the tissues and physiological systems that had already been affected by months and perhaps years of biological stress. And that realization changed the next question. Instead of asking, why isn't detoxification working? We began asking, what still needs to heal? Removing the source of biological stress and repairing the damage it leaves behind are not the same process. Lowering Sarah's environmental burden reduced an important source of ongoing physiological pressure, but her cells still had to restore antioxidant defenses, repair oxidative damage, improve mitochondrial energy production, regulate immune activity, and calm inflammatory signaling. Her tissues and nervous system also needed time to recover after months of pain, poor sleep, reduced movement, and chronic physiological stress. That explained the apparent contradiction. The laboratory values showed that clearance was improving. Her symptoms showed that repair was still underway. These two processes are related, but they're not the same process. Once we understood that distinction, Sarah's treatment strategy evolved. Reducing ongoing environmental burden remained important, but it could no longer be the primary focus. Lymphatic movement and elimination still mattered, but they had become part of a broader strategy aimed at rebuilding resilience rather than simply clearing toxins. The goal was to restore the biology that allows a person to function and ultimately to feel well again. Sarah's illness had once appeared sudden, confusing, and disconnected, but the deeper we looked, the less random it became. Her environmental testing revealed a layered burden. Her swelling, pain, and reduced movement pointed toward impaired transport and lymphatic flow. Her reactions showed that detoxification had to proceed at a pace her body could manage. The falling toxin levels confirmed that clearage was improving. The symptoms that remained reminded us that cellular repair, immune regulation, mitochondrial recovery, and tissue healing follow their own timeline. Sarah's story does not provide a universal protocol. It demonstrates the value of placing the clues in the correct biological order: exposure, transport, elimination, and repair, allowing each new response to guide the next decision. Once those pieces were connected, Sarah's case stopped looking like a collection of unexplained symptoms. It became a biological story we could finally begin to understand. By the end of 4 months, Sarah didn't have every question neatly answered, but what she had was direction. Her retest showed several important markers moving downward, and that told us the program was changing something measurable. But Sarah herself was not yet feeling steady. Her health had been through an extraordinarily tumultuous period, and after such a profound disruption, improving laboratory values was only one measure of progress. Her body still needed time, consistency, and continued support to regain stability. Sarah remained with the program for another 6 months before she began to feel truly steady. That stability became the key to her healing. Her story was never about finding one villain or producing a rapid transformation. It was about helping a deeply disrupted biological system to settle, recover its footing, and gradually become more resilient. The laboratory changes showed that progress had begun. Feeling steady 6 months later showed that recovery was finally taking hold. Once Sarah began to feel steadier, the work became increasingly practical. I taught her how to prepare medicinal herbs and gradually introduced binders and other detoxification supplements, adjusting the timing and dosage according to how her body responded. The goal was never to push harder, it was to keep moving forward without disrupting the stability she had worked so hard to regain. Much of this journey also unfolded during menopause. While menopause didn't explain the full severity of her illness, it influenced many of the same biological systems already under strain, including sleep, energy, mood, metabolism, and recovery. Progress remained gradual. There was no single supplement, herb, or laboratory result that restored Sarah's health. Recovery came through patience, careful adjustments, and giving her biology the time it needed to heal. If you'd like to see Sarah's actual laboratory results, the graphs, and a more detailed discussion of the biology behind this case, you'll find links to both parts 1 and 2 of her story in the video description below. Looking back, Sarah's story reminds us that healing is rarely fast or linear. It unfolds through thoughtful observation and individualized care, and supporting the body's remarkable capacity to recover when the underlying biology is understood. So thank you for joining me for Sarah's story. I hope it reminds us that symptoms rarely exist in isolation. And if you're interested in understanding the biology behind chronic symptoms, not just the diagnoses, please subscribe, and I'll see you in the next episode of the biology series. Bye for now.